Hello, hello. This is Transformations Part 2. This time it's reflections. Reflections are pretty easy too, so you guys shouldn't have that much trouble with it, just like translations. So let's get started with the basics. So, as you saw from the title page, a reflection is basically just flipping an image about a line. That line is called the line of reflection, and you're trying to make a mirror image around that line. So let's say point A is the pre-image, and this is the image, the final image. Then you're just reflecting it around this line. So the rule about this line is that the line of reflection needs to be the perpendicular bisector of the segment between the pre-image and image points. So let's just write that down. Perpendicular bisector of, let's just write segment. But these 2 points could be any points. It just needs to be, the line of reflection just needs to be the perpendicular bisector of the segment connecting the corresponding pre-image and image points. So now, for example, I've drawn 2 extra points. And let's say that this was a complete triangle and that you were trying to reflect it to this side. So you would have to draw the perpendicular to the line of reflection from each of these points, and also copy this distance over here in order to make this line of reflection the perpendicular bisector of the segment. So after you copy this distance over here, then you get the point that is the other end of the segment. So this is going to be the image point. And you repeat the process over here, draw perpendicular. That is, draw the line that's perpendicular to the line of reflection, copy the distance, and then you have your image points. So let's do some practice problems. So the first one brings up a question, like, what if one of the pre-image points is on the line? That question is actually pretty simple. The image point will also be on the line, since you don't have to move it anywhere. You don't have to reflect it across. So let's work with the rest. So we just eyeball it, draw the perpendicular, and then you copy the distance from the pre-image point to where it intersects the line of reflection, right there. So let's just measure it out. That looks to be about 1/2 inch on my ruler. So I'll just copy that over there, and we'll repeat the same process over here. So then after that's done, then you just connect the dots, and you have your reflected image. So that's pretty easy. So just remember, you just need to draw the perpendicular from the pre-image to the line of reflection, and copy the distance from the pre-image point to where the line intersects the line of reflection. So I'll just draw that so that you can be reminded. And remember that if the point is on the line of reflection, then it stays in the line of reflection in the image afterwards. So now let's do some other shapes. This is like these other 2 that I've already showed you, except now you have all 3 points that are not touching the line of reflection. So you just have to draw 3 perpendiculars this time instead of 2. Let's draw 3 perpendiculars and then measure the distance afterwards. So this is about 1 inch. Oh, that didn't draw all the way. A Sharpie? Okay. Sorry about that. Close enough. Okay, so 1 1.25 inches it looks like. So we'll make that over there. This looks to be 1/2 inch. And about right here. And then you would just connect the points. And then let's go on to the last synthetic question that we have, which is to reflect a square. So just be careful, since these lines will be on top of each other from this point and this point, and you just have to be careful and remember which one you're doing at the time. So it's not exact, but it's close enough, which is what you need. That's all you need to do with these kinds of questions. You don't need to get it precisely the exact distance and perpendicular. It just has to be, it has to look okay. So now let's move on to some special rotations. So most questions that you're going to see are going to involve these three lines of reflection because these are the easiest. They have their own special formulas that you can use to find out which point you should reflect to. So these are our special rotations. So the first line of reflection is reflecting across the x-axis, or where y equals 0. So let's say you have point xy. To reflect that point across the x-axis, you simply change it to x negative y. So let's say we have point 1, 1 over here, so 1, 1. To change that and reflect it across the x-axis, then we just need to change the y to negative. So 1, 1 would become 1, negative 1. So you just turn it down here. Now the y-axis is where x equals 0. And that's our next special rotation. So when you're reflecting across the y-axis and you have point xy, the formula to reflect the point would be negative xy. So let's say we have 1, 1 again, and we want to reflect it across the y-axis. So we would change the x-coordinate negative, so it would be negative 1, 1. So this would be our reflection across the y-axis. And y equals x is our last line of reflection. The line y equals x would look something like this. So let's choose another point. Let's say we have 1, 3. And we want to reflect that across line y equals x. So if you have a point xy and you want to reflect it across line y equals x, then you just change it to yx. You just swap the x and y coordinates around, so the y coordinate becomes the x coordinate and the x coordinate becomes the y coordinate. So you have 1, 3, and to reflect it, you just follow this rule, yx, so that'd be 1, 3, it would turn into 3, 1. So then you'd get this. So this point and this point would be reflected images of each other. But one more case comes up where, what if you have a line that isn't any of these? Like, let's say you just have any line of form y equals mx plus b. Like, let's say for the purposes of right now, let's say you have y equals 2x. How are you going to do that? So first of all, line 2x would look something like this. Let's use another color. Line y equals 2x would look something like that, that orange line. So, and let's say you had point negative 3, negative 1, right there. We'll call that point A. And you want to reflect it across that line. So how are we going to go about doing that? So we're going to use our knowledge that the line of reflection must be the perpendicular bisector of the image and pre-image points. So as I showed you earlier, then if this was point A and this was the image, then the line of reflection is the perpendicular bisector. So we're going to use that rule right here. So first, we would find the perpendicular to the line of reflection that contains the pre-image point. And then we're going to find the other end of the segment that would make this line of reflection the perpendicular bisector. So first, let's find the perpendicular to this line. So to do that, we just need to find the slope. We already know the slope is 2, so the perpendicular slope would be negative 1/2 since it's the negative reciprocal. And we need to find the equation of the line. So let's just use point slope form since we already have one point and we know the slope. So this point is negative 3, negative 1. So we'll just plug that in. So now we have the line that would be perpendicular to this. So now let's find where it intersects the perpendicular. Or let's find out where this line intersects the line of reflection. So to do that, we'll just set them equal to each other and solve. So this is just a system of equations, and we're just solving to find the solution. Let's just multiply it by 2 so we don't have to work with fractions. So I've worked it out so that they intersect at negative 1, negative 2. So -1, -2 is the point where the line containing the pre-image points and the image point is perpendicular and intersects the line of reflection. So this is the midpoint of that segment between the pre-image and the image points. So this point would be -1, -2. In order to find the image point, you can just use the midpoint formula, which is to find the midpoint of 2 points, x. Let's say you're trying to find the midpoint of these 2 points, x1, y1, and x2, y2. In order to do that, you would just add up the x-coordinates and divide by 2, and add up the y-coordinates and divide by 2. So we're going to use that in order to find the other point, since this is our midpoint right here. So we should make 2 separate equations, one solving for the x-coordinate and one solving for the y-coordinate. So we already know what the midpoint is. The x value of the midpoint is -1, and the y value of the midpoint is -2. So, and we also know what one of the points is. So we can solve like this. So now we've solved it. We've got that the other point on the segment was 1, -3. So we can plot that in, and that would be the image, the reflected image of point A, right there. So we can just show right here, that would be perpendicular, and this distance would be congruent to this distance. So now let's do some analytical problems. So the first one asks us to reflect this triangle across the x-axis. And we learned from earlier that if you want to reflect a point across the x-axis, you change it from xy to x -y. So on a coordinate plane, you don't actually have to write out all these points and then convert them manually. You can actually just count how far it's away from the x-axis. So this is 1 point away from the x-axis, so we can count down 1. This is 1 away from the x-axis as well, so we can count down. This is 3 away, so we can just count down. And then when you're done, you can just connect all the dots. So now let's do this one. And it gives us 3 points, and it tells us to reflect that across the y-axis. So let's just draw those points first. 1, 1, 4, 3, 2, 6. So since you already have all these points here, then you can just convert them to the -x, because you know that if you want to reflect something across the y-axis, you change it from xy to -xy. So let's just do that right now. So now you have all these points, then you just conveniently. Of course, if they didn't give you the points and they just gave you the shape, you could do the same thing as we did over here and just count over the distance from the y-axis and repeat it on the other side. So now it asks us to reflect across y = x. So we know that if you want to reflect something across y = x, then you have to change it from xy to yx instead. So you could do this in your head, or you could write it down. I'm just going to do it in my head. If you find it difficult to do stuff like this in your head, of course you can write down -2, 1, and then manually change it to 1, -2. But I would just do this to make it go faster. So 1, -2. -3, 3 would change into 3, -3. -4, 3 would change into 3, -4. And -5, 1 would change into 1, -5. So then you can just connect the dots, and then you get your reflected image. Remember, you're reflecting across this line. So, of course, you could see that this would be perpendicular, this is perpendicular, this right here is perpendicular, and that's perpendicular. So now let's do the last one. It's a hard one. Reflect across y = 3x + 1. So let's just draw in y = 3x + 1, just so that we can see what it would look like. We can kind of guess based on what the line of reflection is. So it kind of looks something. Let's use a pencil. It would look something like this. So you should be, when you have your answer, you should check it to see if it looks similar to that. So as I showed you earlier on with just 1 point, we have to find the perpendicular to the line of reflection that contains each of these 3 points, Then we need to use the midpoint formula in order to find the other end of the segment, and then that will be a reflected image, since the line of reflection would be the perpendicular bisector of each of the three segments. So I'll do the first one with you, and then I'll do the other two on my own. So let's start the slope. Let's just choose one point right now. So this point right here, that point is -2, 1. So we know that the slope is 3, so the perpendicular slope would be -1, 3. So let's just use the point slope formula in order to find the line that this has to be on. So now we have the equation. So y equals -1/3 x plus 1/3. So that is the line that is perpendicular to the line of reflection and contains the point -2, 1. So now we have to find the point where this line and this line intersect. So we'll just solve for that like earlier. So now we have this point, -0.2 and 0.4. That is the midpoint of the segment that contains pre-image and the image. Now we need to find the image point. So we'll just use the midpoint formula. So we have our first point, 1.6 and -0.2. So it would be somewhere right there. So I'll just do the rest on my own, and I'll see you. Alright, so I've figured out all the points, and I've confirmed that it is the same triangle, as in the points are the same distances apart. So now let's just connect the dots. And you can see that this is a reflected image of this original triangle. So this would be perpendicular, always perpendicular. So what we've done is found the perpendicular from each of these points to the line of reflection, found the point where this line intersected the line of reflection. That point was the midpoint of the segment between the pre-image and the image, and we used that to find the image point, if that makes any sense. So, hope that helped.